Children, taking some more examples or we can say questions from exercise 2.1 on Cartesian product of two sets. Okay, let us extend it to Cartesian product of three sets. See, question number 5 is about that only. If set A is having elements minus 1 and 1, then you have to find what is A cross A cross A. Fine. So first we will find Cartesian product of A with itself. So you can quickly look at this diagram. We have to find A cross A. A is having elements minus 1 and 1. Same over here. So you have to see how many pairs minus 1 and 1 can make with these minus 1 and 1. That will give us A cross A. You can quickly see minus 1 can pair with minus 1 then with 1. In the same way 1 can pair with minus 1 and then with 1. So we get these 4 pairs. Now extending it to A cross A, which we can write as A cross A. So this is one set. It Cartesian product with A. So now what we have to do? We will write the pairs of these 4 ordered pairs with the elements of A. So see how it goes. This will pair with minus 1. This will pair with 1. In the same way then this will pair with minus 1 and then this pairs with 1. And in the same way the next two ordered pairs also. This is an easy way of writing a pair of ordered pair with another number. So see the first one, it was minus 1 and it is pairing with minus 1. So this is how it can be written. Then this pairs with 1. So minus 1 and 1. Like this you pair all the ordered pairs with minus 1 and 1. See the third one becomes minus 1 comma 1 comma minus 1. Then minus 1 comma 1 and then 1. So 4 pairs we have written. Then 2 pairs from here, another 2 pairs from here. So 1 comma minus 1 comma minus 1. Here it is. Then 1 comma minus 1 comma 1. That's here. Then the last pair minus 1 pairing with minus 1. And minus 1 pairing with 1. So this is Cartesian product of A with A and then it's Cartesian product with A. Now the sixth one, A cross B is given to us. Cartesian product of A and B. They are asking you to find the sets A and B. So we will look at the elements of A cross B. From there we will try to define what is A and what is B. If you can recall the definition for Cartesian product, it says it will contain ordered pairs where the first element of ordered pair will belong to the first set and the second element will belong to the second set. So keeping that in mind, if I see these are the 2 ordered pairs having A as the first element, we'll write A only once. Then these 2 ordered pairs are having B as the first element. So set A can be defined as having alphabet small a and small b. In the same way, the second elements of the ordered pairs will belong to set B. So what are the second elements? X and Y. So set B is also a set with 2 elements X and Y. Now moving on to 7th, set A is given as having element 1 and 2. B has got elements 1, 2, 3, 4. C is having 5 and 6. D has got 5, 6, 7, 8. And we have to verify that Cartesian product of A with B intersection C is same as intersection of A cross B and A cross C. Before verifying this, we will have to evaluate some of the terms. Okay, some of the sets we need to evaluate. Before taking this Cartesian product, we should know what is B intersection C. So you focus on set B and set C. What is their intersection? That means we are talking about intersection of the set containing the numbers 1, 2, 3, 4 and another one containing the numbers 5 and 6. Do you see anything common among these two? There is no element common, so this reduces to a null set. Now come to the left hand side. Left hand side talks about Cartesian product of A. A is having elements 1 and 2 and its Cartesian product we need with the null set. See how do we write Cartesian product? You can see the previous question. For that we try to make all possible pairs of the elements of first set with the elements of second set. If you see here the second set is a null set. So there is no pairing possible. We don't have any element here. So the Cartesian product of A with B intersection C. See, this can also be written as A cross null set. Understood? Because B intersection C came out to be null set. So the Cartesian product will be a null set only. That means in the Cartesian product there is no element. Fine. Now in order to see whether even the right hand side will come out to be same, we will first write A cross B and A cross C. Then we will see what is their intersection. Okay, let us write for A cross B. So only focus on set A and set B. All the pairs which 1 will make with all these 4 and all the pairs which 2 will make with all the elements of B. So first let us write the pairs with 1. So 1 can pair with 1, it can pair with 2, it can pair with 3, it can pair with 4. Then the second element of A is 2. So 2 will pair with 1, 2 will pair with 2, 2 will pair with 3 and 2 will pair with 4. So this is A cross B. Then let us check the other one, which is A cross C. So this time pairing of the elements of A with C. So first 1 will pair with 5 and 6, then 2 can pair with 5 and 6. So the possible pairs are 1, 5, 1, 6. Then 2, 5 and 2, 6. Okay, so this is A cross C. Now right hand side is A cross B intersection A cross C. So both the sets are available. A cross B as well as A cross C. You check, is there any pair common to both? You will find all the pairs in A cross B are not in A cross C. And none of the pair of A cross C is in A cross B. So what do we find? This comes out to be a null set, same as the left hand side. So the result is verified. Now in the second part we will verify whether A cross C is a proper subset of B cross D or not. A cross C we have already done in the first part. I have marked it. Equation 1. B cross D we can quickly evaluate. See how many pairs we will get here. 4 into 4, 16 pairs. 1 will pair with 4 elements, 2 will pair, then 3 and then 4. So I'll quickly write down those. So 1 pairing with 5, then 1, 6, 1, 7, 1, 8. Then with 2, 2, 5, 2, 6, 2, 7, 2, 8. Then 3, 5, 3, 6, 3 with 7 and 3 with 8. In the same way, 4 pairs with all these, 5 with 6, with 7 and with 8. Okay, so this can be marked as equation 2. Now you compare 1 and 2 and then see, are all the pairs of A cross C in B cross D also? So see, 1, 5 is available, then 1, 6, we have 2, 5, we have 2, 6 also. So we can write A cross C is a subset of B cross D. This we get from 1 and 2.